Development of web applications usually starts with a Java or PHP application that sits on a server, and in order to store state about whatever the application is serving as a purpose in a relational database. So we'll store state. If it's an e-commerce system, it will be data about the products and so on. If it's a social network, it will be content that the users are creating and so on. And what the web application creates, which is returned to the browser, to the customer browser, is essentially HTML, CSS, and JavaScript. And that sits on the client side. And when you want to scale a web application, there's two sides to it really. There's the client side and the server side. So I'm going to focus on the server side of things, but there's a lot of things that you can do on the client side to optimize how the browsers use and fetch content and so on. So one of the first things is once the web application starts to reach a certain scale in terms of how many customers are accessing it, the latency becomes an issue. So your web application is not only serving the pages themselves, but it's also serving images, JavaScript files, CSS files, and all the static content that it doesn't need to serve. So a content distribution network is sit between your web application and the client and usually serves the static content. And another advantage of a CDN is that not only does it take the burden of serving the static content of your web application, but it also sits closer to the clients in terms of network travel length really. So the distance between the client and the CDN will always be less than the distance between the client and your web application. Because what CDNs do is they have high throughput networks sitting in lots of different locations all across the world. So Akamai, I think, has over 1,600 locations, and other CDNs like Fastly have less than Akamai, but they still do have a huge presence all around the world. So the travel time for the request to go from the client to all the way to your backend server doesn't need to happen. Once you start to have more users, there will be a high load on your database server. And in the context of web applications, usually this is more read-only traffic that's heavy. So the writes are usually less than the reads. So one of the first things that you will have to do as an optimization is to separate out your writes from your reads. So what you do is you point your web application to carry out the writes to one master database, and then that master database will asynchronously update a read-only database, and your web application will carry out this read from the read-only database. The read-only database will be slightly out of sync with the master database, but we're talking about milliseconds here, so it's not really noticeable for the users. Once you've resolved that issue, you're likely to encounter another issue around scaling, and that's the web application itself. So the load on your server, which is processing all the requests, retrieving data from the database, putting it together in a particular form, and creating the web pages, that's going to be too high based on the other optimizations that you've done. Now you have more traffic coming through, and the bottleneck is likely to be that. And the solution for that is to have multiple web servers running your applications, and the traffic will need to go to those web servers using a load balancer. So that could be a big IP load balancer, or if you're using a cloud solution like AWS, it could be an Elastic load balancer, an application load balancer that you sit in front of that. Then the next hindrance that you're going to have in terms of performance is likely to be the reads from the database. So when you're reading from a database, in most cases, the database will actually access a physical drive, as in a hard disk drive, whether it's a solid state disk or a magnetic hard disk. And those usually have higher latency in comparison with RAM, which is random access memory. So if you use a caching solution like Redis or Memcached, the reads won't actually hit your database. They will be read from the cache, from the memory. And that will be maybe 10 milliseconds or even less than 10 milliseconds, whereas if it was going to the read-only database and had to be read from disk, it would be definitely more than 10 milliseconds, maybe 50 milliseconds, potentially even more. So you'll gain a huge benefit from actually putting a caching solution like Redis in front of your database. Now, the other thing is when you actually put caching in front of your database, what you need to do is change your web application's data access layer to invalidate the caches and perform the writes to the database and invalidate the cache, and make sure if the data doesn't exist in the cache, read it from the database and update the cache. So if you want to not have to repeat that every time for different parts of your application or different applications that are actually accessing the same data, a good solution would be to have RESTful APIs in front of that. So you put some of your business logic and potentially even most of your business logic and data access layer in REST APIs, and the REST APIs will actually communicate with your caching layer and your database and so on. So your web application should have less and less responsibilities, in particular regarding accessing data that sits on your relational database. And that's really good because it means you can also have other clients accessing your REST APIs like mobile devices. And that's the next point I wanted to talk about. Once you do have REST APIs, you have a web application that's serving the web, and you have your REST APIs that are serving mobile clients. So, and by mobile client, I don't necessarily just mean mobile phones. It could be tablets, mobile phones, watches, smart TVs, and it could even be other things that you actually use for integration with other services. So if you have a webhook of some sort from another application, you can use the APIs to, I don't know, I can't think of a good example, but if you're, for example, integrating with Slack or one of these services, if this then that, to actually trigger certain events, you can all do it through the REST API, and that would be a lot easier than actually having to develop another web application to take care of that. And just like your web application, your REST APIs can have caching as well on the edge side as a CDN. So you could have something like AWS CloudFront, or in particular if you use something like AWS API Gateway, it caches your responses with CloudFront automatically as long as you choose to do so. And that will take the burden off your backend servers. So if there are responses that can be cached, you can cache them there. And the other advantage is if you are using AWS to run your infrastructure, putting your request through CloudFront not only reduces the network latency, but also the network connection between the CDN being AWS CloudFront and your server-side environment, which sits on AWS. That network connection will be a specific high-throughput network that will be provided by AWS. So even if you're not caching anything, you will still gain something just by putting CloudFront in front of your requests, whether that be for your web or for the APIs. Now the next hindrance you're going to encounter is likely to be writes on the database. And I've intentionally put that after adding mobile devices and mobile clients there, because by that time probably the traffic of the web application and mobile applications will be so much that you would need a database cluster to accommodate the writes. Managing database clusters is actually quite difficult, and in my experience you do need people with the right skills, and it is an ongoing maintenance cost that's quite high. So if you can just scale up that single database node, I would recommend you do that instead of creating a cluster. But you might reach a point where you want a certain amount of resiliency and performance that you might not be able to get, or it might become infeasible in terms of cost, and you don't have a choice. So creating a database cluster will deal with the issue of high throughput on the writes. Sorry, not reads. And the other thing usually pretty much every application does is you want to get data out of your system and fetch it in some sort of analytics system or BI tools and so on. And that's typically what you do with an overnight ETL. And this is how things have been done historically. So if you come across a legacy system, there's a high chance that this is how it has been built and what the overall structure looks like, more or less. So I haven't included any streaming in this architecture or any distributed asynchronous calls, really, apart from the database read-only system, which takes the database logs and updates the read-only database. So this is a typical legacy application that you come across. And at this point, there isn't a huge deal of problems with this architecture. It's only that to scale this further and cope with the amount of demand that might increase in the future, it will be quite difficult to keep the architecture as it is. And the second thing is around development of new products and features, because everything is one system, or part of one system anyway. Whenever you need to develop a new feature, you need to touch every point in this architecture. So you probably have to change something starting from the database. Maybe you need some new fields, and then you need to expose that data through REST APIs. And you also have to accommodate that data being stored in your caching system. And then the web applications will need to be modified to read the new data from there and present the data in a different form to the clients. And the same thing goes with mobile. And also your ETL system that stores data for a BI tool, for example, that needs to be updated as well. So even developing a new small feature or a new small product will have a huge impact on all the areas of the system that needs to be touched. And there's obviously a way to deal with this, but it involves re-architecting the landscape and also the company organization in terms of how staff are working on different systems to accommodate that. So typically in the past, how projects were delivered were you had a project manager and you had a number of staff from different functional teams coming together for a project, working on the project. Now, if you have multiple projects running at the same time, they will need to coordinate things together to make sure they don't make changes that will affect the other project. And also there's a certain amount of skill that each software developer or system administrator or database administrator has that not everyone else knows about. So what would happen is these project teams would actually have dependencies on the other project teams. So it would be impossible to actually try to predict how long it takes to develop something, because there were circular dependencies between the people working on each of these projects. And the communication and dependency overhead was quite a lot. So it wasn't just from one team to another team. The reality looks more something like this, where the project manager is talking to different staff in the company and trying to organize things, and the software developers and database developers, everyone is doing the same thing to try to get the issue resolved. So the main reason for that is that teams were based around expertise. So you would have software engineers and their expertise was developing softwares, and then you had system administrators and their expertise was how to manage and deploy the system. You had database administrators who were managing your database cluster. And the way to deal with that is to have cross-functional teams that are actually organized around a particular feature, particular product, or particular domain within the business. So it depends on the scale of the company, how you want to create these teams. And what happens is companies usually are quick to do an organizational restructure. So they move from having functional teams to having cross-functional teams, but the underlying systems don't usually change with that. So the transition really fails. And what's more important than actual teams is to change your applications and break it down into smaller pieces where each functionality or feature sits within one area and one team supports that. And the way to move from those legacy web applications to a kind of microservices architecture is quite complex and context dependent, so I'm not going to go into the details of that now, but you can end up in various states for various different parts of the system, which might not be desirable. But overall, this is the type of architecture you end up with after you have scaled as much as it's really feasible for a web application.